Okay, we'll look at our last module, Module 14. We study exponential equations. I want to look at solving some exponential equations. And to do that, we'll work on isolating the exponential term. Right, so again, our exponential term will be our term that has our unknown in the exponent, our variable, like x, that we're trying to solve for. In order to solve for x, in order to get it out of the exponent, we'd like to be able to get the same base on both sides using exponent properties. So we can get, for example, a to the m power equal to a to the n power. Right? If both sides had a base of a, then we know that the bases are equal. Then the exponents we could drop down and set those equal to each other. So again, that allows us to solve for what's up there in the exponent. If you can't get the same base, we're going to introduce logarithms, and we can introduce common log or natural log just to make it easy to check on our TI. Use log base 10, log base e, and we can solve it with logarithms. So with that said, let's go ahead and look at example A. And here's a problem where, again, our unknown, our variable, is up here in the exponent, and it wants us to find out what x equals. Well, right now we got a base 4 exponential term on the right side and on the left side. And the right side we have 64, which is a number we can rewrite base 4. So we can get the same base on both sides. So our exponential term is already isolated. If there's anything with it, we want to get rid of it, but it's already by itself. But I'm going to go ahead and rewrite 64. We all know that 4 times 4 times 4 is 64. 4 cubed is 64. 4 times 4 is 16. 16 times 4 is 64. So now that the bases are equal, we know that these exponents are equal. So we can drop down the powers, right, and set those equal to each other. So if negative x equal 3, right, we multiply both sides by negative 1, and we come up with our solution to the exponential equation, and that x equals negative 3. Right? And you could check it. Right? Does anything with equations, we like to check our work, check it graphically. Right? You could check it by substitution. So again, if you plug in negative 3 into x, so let's do a quick check step. So with x equal negative 3, we know 4 to the negative of negative 3 power. Taking out x, plug in negative 3, we get 4 cubed, and 4 cubed is 64. So it does check. As we go to example B, all right, we've got another exponential equation. Now as we're looking at our unknown, here's our exponential term. We've got 3x minus 1 up here in the exponent of this base 2 exponential. But our first step is we need to isolate the exponential term. So we need to go ahead and add a 4 over to the right side of the equation. So that'll give us 2 to the 3x minus 1 power equal to 32 as we add that over to the right side. Now with that said, we can rewrite the right side, right, base 2. So we can get the same base again. So we all know that 2 to the 3x minus 1 power equals 2 to the 5th power. 32 is 2 to the 5th power. 2 times 2 times 2 times 2 times 2 is 32. So now that we have both base 2 exponentials, we can drop down these exponents, right? And we can set those equal. So 3x minus 1 equal 5. And then we can solve our linear equation. We can go ahead and add the 1 over, and that gives us 3x equal to 6. And then we can divide out our 3 on both sides, and we have our solution of x equal to 2. And again, you can check it, you plug it back in with substitution, and see if it checks, which it will. You plugged in 2 for x, you get 3 times 2, which is 6. 6 minus 1 is 5. 2 to the 5th power is 32. 32 minus 4 is 28. And let's look at this next example, example C. All right, we've got 3 to the x squared plus 4x power equal to 1 over 27. So again, here's our exponential term. Again, I want to find out what x equals. We need to go ahead and isolate if it's not isolated. So that part is already done for us, right? It's already by itself. Now on the right hand side, I noticed that I have 27 down here in the denominator. Well, this is base 3. Well, let's rewrite 27 base 3. So we've got another number that we can convert over to the same base as the other side of the equation. So that'll be 1 over 3 cubed, right? 3 cubed is 27. Now 3 cubes in the denominator. We want to get rid of this fraction. Let's bring it up to the numerator. So that gives us 3 to the x squared plus 4x power equal to 3 to the negative 3 power. As I reciprocate, I change the sign of the exponent. So since the bases are equal, right, we know these exponents are equal. So x squared plus 4x equals negative 3. And then what? We're going to solve our resulting equation. Let's solve the quadratic. So we'll go ahead and add 3 over. So we got x squared plus 4x, right, plus 7. I'm sorry, right, correct me. Plus 3, right, equal to 0. And can we solve? We'll solve by factoring. We know, again, every quadratic trinomial, we got these two linear binomial factors. This one factors nicely with integers. We need an x and an x up front for the x squared term. We know the factors of 3, 1, and 3 will work together to make the middle term coefficient, right, of 4. Outer inner product of 3x and 1x, they add up to 4x. So in the end, we've got our solutions, right? X plus 1 can equal 0. We use our zero factor property. Or x plus 3 equals 0. And as we're solving x, x equal negative 1, or x equal negative 3. And at that point, again, you can check it. So again, there's our two solutions, right? And you can plug it back in. For example, negative 1 squared. Let's plug it in up here in the original equation. Take out x. X squared would be negative 1 squared, which is 1. 4 times negative 1 is negative 4. And that's a negative 3. We add them up. 1 plus negative 4. And you have 3 to negative 3 power is 1 over 27. And the same thing happens with negative 3. We square negative 3, we get 9. And then we got 4 times negative 3, which is negative 12. And that adds up to negative 3. And you get 3 to negative 3 power, which is 1 over 27. So you see our two solutions, right, to the exponential. And just remember, on exponentials, we have no restrictions on x. Remember, domain is all real numbers. Unlike logarithms, we have to be careful. We can't take the log of a negative, but not having to worry about that with exponential equations. All right. So again, we're solving exponentials. So those we're able to solve by using the same base on both sides of the equation. All right.